Testing, testing. I'm not sure. Who knows? Let's try that. Let's try completely muting. There's no YouTube audio. I mean, that's not what you want, right? Alrighty. We are live. Let's see what's happening here. All right. Welcome to the. Oops. All right, welcome to those that want to or need to join the second section. We do need to keep both sections running just like the normal class did, because people might not be able to do a 9:30, people might not be able to do a 10:30, so we will have duplicate classes just like always. So today is all about testing to see what works, what doesn't work on my end, to see what works, what doesn't work on your end. I don't know if anyone is trying out the second stream, but let me know in Discord if you are. Otherwise, I'll just be talking to myself, which I do most of the time anyway. So, what I thought we could do is maybe go over areas of the polygon, the 4 area formulas, because we still have this bonus assignment, I'll call it. I can't call it a pop quiz anymore because it's not poppy, really, and if it's a take-home quiz, it's more of an assignment. But regardless, we still have this bonus opportunity where I will give you 4 shapes, and those shapes will be, whoa, that is a horrible A. We want to find the areas of a rectangle. Then we'll talk about a parallelogram. Then we'll talk about a triangle. And then we will talk about the trapezoid. There are others, of course, but we just want to have a basic understanding of area formulas, and these will do the trick. I'm going to do them in this order as well to make a little more sense of where the formulas come from. So first up will be a rectangle. Let's draw a rectangle. Let's suppose it has length L and width W. Then just based on the area concept of fitting unit areas into a space, the area formula is going to be length times width. So the first part of the bonus assignment will be giving you a rectangle with length dimensions, and you have to calculate it. Next up will be the parallelogram. Parallelogram. This tablet is a little different than my previous one, and I can't seem to write very neatly on it. I might swap out for the other one. Anyway, let us draw a parallelogram. Doesn't have to be perfect. So the dimensions, the measurements that we will be given will be the length as well as the distance between the two. Now, why do I call this W? Because the rectangle and the parallelogram are very closely connected. If I imagine fixing the bottom edge here, the bottom side, and having some sort of rubber material, and I push the top, then what I'm going to get is a parallelogram. And because I pushed it perfectly parallel to the bottom side, the distance between the two lines will still be W. So I'm not going to be concerned with the side length of the parallelogram, but the distance between the parallel sides. I can now think of the parallelogram as having a fixed bottom edge and pushing the top one back to deform it back to the rectangle you see above. And because they are essentially the same, just one is a deformed version of the other one, it makes sense that the areas are the same and the area formula looks the same. However, in the case of the parallelogram, it is the length of a parallel side times the distance between those parallel sides. It's not necessarily called the width of the parallelogram. Now we could be given this other side length, but to keep things as simple as possible, right now we're not going to worry about that. That could come up a little later, so I'm not going to worry about that right now. It is something that we have to be able to handle, but not right now. All right. Next up, we will look at the triangle. Let's draw any old triangle. What we're going to have is the length of a side. We'll call it B for base. It doesn't matter which one it is, but you pick a side for the base. And then I'm going to need to know the perpendicular distance from the base to the opposite vertex. And we're going to call that h, the height of the triangle. Then the important thing to note is what we've observed with tessellations. We said that all triangles tessellate the plane, and our reason for that was that if I take a triangle, any one, and I make a copy, and essentially by flipping it on this edge, for example, what will that look like? What I'm creating from my original triangle is another triangle which is exactly the same, but now I've created a parallelogram. And I know the area of a parallelogram. Area of, I'm going to write it like this, parallelogram. That is, well, the length of a parallel side is B. The distance between those parallel sides is now h. However, that's not really what I'm looking for. The area that I've now calculated is 2 times the area of the triangle that I'm interested in. So therefore, the area of a single triangle, just one of the copies, is a half base times height, which may be familiar to many of you, but it's also beneficial to know why the area formula is what it is. That gives me confidence to know that, ooh, maybe I don't remember the formula right on the spot, but I know how to get it. So I have more confidence in that. If I have to blindly memorize stuff, I lose confidence very quickly. So it's good to know what the formula is and why. And because this is now going to turn into a take-home assignment, you can very easily look it up as well. So it just becomes easier. Next up is a trapezoid. Let's draw the trapezoid. This is sort of the classic one I think of. What do I need to know here? Well, I need to know the length of the two parallel sides, and I need to know the distance between them, which I'm going to call the height. Why do I call it the height? Because I can see any quadrilateral as being split up or made up of two triangles. Like that, for example. The first triangle is, or has, base A and height H. The second triangle is a little skewed, but I can see the B edge as its base, and then the height is the perpendicular distance from the opposite vertex to the line which may be extended. That's H as well. So the area of triangle 1 is a half base times height. The area of triangle 2 is also a half times the base times the height, but the base is B. The height is H. So now I have the first triangle and the second triangle. So the area of the trapezoid is area of triangle 1 plus area of triangle 2. Come on. Now I can simplify this, taking out a half, taking out the h as a common factor, and I have a plus b left. So the area of a trapezoid is a half times the sum of the lengths of the parallel sides times the distance between them. Why? Because it comes from breaking up the quadrilateral into two triangles. So knowing where it comes from, knowing why it is what it is, gives me confidence if I happen to not remember the formula perfectly. So in the week of the 23rd, we will have, let's say, a take-home assignment. I'm not going to call it a quiz. It's not timed or anything. You do it however you want. But it gives us practice to see how do we scan something, how do we send it back, how am I going to do that, so that when the tests come, and they will come, quiz April 8th, final exam 17th, I then know how to scan my answers and send it back. So with this, yes, it's bonus, it's optional, but I can see it as a practice, as a trial run to iron out any scanning and emailing kinks that might happen, because you don't want there to be any surprises during an actual test. Of course, all of these will have to be emailed back, and the portfolio assignment will also have to be emailed now. Everything has to be electronic. Those, for those that already handed in their paper answers for the first bonus assignment, I have those, but any others will have to be emailed. And the portfolio assignment will have to be emailed. You can take pictures, you can drag that into a Word document if that's easier, and email that, as long as what you're submitting, bonus assignment, the arithmetic ebook bonus, portfolio, quiz, anything, as long as that is a single PDF document, that is pretty much the only requirement. Always have a backup as well. If you scan something and maybe email it to yourself first before you email me. Sometimes the free scanning apps don't always send the email as they should. So send it to yourself first. Then you always have a backup if I need to ask again. Are there any other comments or questions if you are in fact watching? All right, well, feel free to use Discord. I'm trying to create our classroom environment where we can have discussions. Most people prefer to chat, but voice chatting is always an option. I'm happy to do whatever. We'll still have office hours. Everything will be as close to what we're used to as possible. Feel free to comment or critique or advise anything you want. And then tomorrow we will start with our next chapter on trigonometry. Until then.